Hi, in this session we are going to discuss the first group of external measures called matching-based measures. For matching-based measures, we will first introduce purity versus maximum matching. We still use a similar notation. Suppose we have ground truths, we get three categories. T1 actually marked as the brown points. T2 marked as green points. T3 marked as black points. These are the ground truths. Then the clustering we finally got is cluster C sub 1 actually is marked as the ellipse of the orange color. Okay. C2 marked as surrounded by the red color. And C3 is surrounded by the black color. So what is the purity? Actually quantifies the extent that cluster C sub I contains the points only from one ground truth partition. Suppose we have R clusters finally we get. So for purity sub I, actually is you first count how many points in this cluster. Then you try to see the maximum number of the ground truths here. The maximum number of ground truths actually the black points. You will see the max number is 1, 2, 3, 4, 5, 6, 7. So you get this one 7, but the total number is 9. So you get a purity is 7 over 9. Okay. Then what is the total purity of the whole clustering, C? Essentially, this total purity is each one's purity. Suppose you have R clusters. Each one's purity get their corresponding proportion. So you add them together, so that's the total purity. Or you can transform this formula easily into this one. Okay. Of course, the perfect clustering is in the case when the purity is 1. That means everything is very pure. You add them together, it's 1. And the number of clusters you obtained is the same as the number of groups in the ground truth. Then we look at these two tables. Okay, let's first look at the green table. The green table, the purity 1, that means the first cluster, you get the maximum is 30. So the purity is 30 over the total number of points is 50, so you get 30 over 50. Purity 2, obviously you get 20 over 25. Then purity 3 is 25 over 25. It's really 1. Then the total purity for the whole clustering is, according to this formula, we get a maximum one is 30 plus 20 plus 25 over the total number of points, you get 0.75. Interestingly, if you look at the orange color table, you will get the exact number of the same thing is 30 over 50, 20 over 25, 25 over 25, and finally get the purity is exactly the same formula. But you may find one undesirable thing for this orange color table, because you please see the ground truth T2 totally get 50. They actually was partitioned into two clusters, C1 and C2. That means both C1 and C2 would say we belong to ground truth T2. But on the green table, you probably can see it's different because C1 more pair with T3 and C2 more pair with T2. So that motivates people to propose maximum matching. That means one cluster can only match to one partition. If we have this rule, then we have to find a pairwise matching. That means when we look at this, we look at the weight, we will allow these elements only belong to one cluster. The ij and ij, the ij must be exactly the same. Then if this element belongs to M, then it only belongs to 1. So then we need to look at what is the maximum weight matching. The maximum weight matching simply says you look at the whole group, and then you look at all overall endpoints. you try to find the final matching together should be maximized. For example, if you look at the green one, the max matching is 30 partitioned into T3, T2 pairwise with C2, and T1 pairwise with C3. Okay, that's why green's maximum matching is equal to purity is 0.75. However, for this orange color table, you probably can see is if you assign T2 to C1, then you cannot assign T2 to C2, then you have to assign T3 to C2. Then finally you get this matching is 0.6. However, if you assign T3 to C1, T2 to C2, T1 to C3, you'll get matching is 0.65. To that extent, this assignment is better because the maximum matching, the value is bigger. So that's the reason for the maximum matching, you do have restriction, you have the pairwise assignment. Then another popular used matching-based measure called F-measure. F-measure has been very popular used in information retrieval. F-measure essentially is computed by precision and recall. Let's look at how the precision is defined. Okay. The precision defined is for this particular matching, what you want to see is for precision C sub I, what you want to find is what's the maximum one matching this particular cluster, then divide by the number of total number of points in this cluster. So in that sense, your precision actually is the same as purity. That means if you get a fraction of C sub I from the majority partition of C sub j, then the j's partition contains the max number of points from C sub I, then you get this formula. For this formula, you get the precision and the purity. Actually, this point is the same. You get 30 over 50, 20 over 25, and 25 over 25. Okay, that's the precision. What about recall? Recall actually is the fraction of the points in the partition shared in common with cluster C sub I. Simply says, if you assign T3 to C1, what you want to see is you get 30, but T3 actually got 35 ground truths. You only capture 30. That means your recall is 30 over 35. That's exactly, you can see the formula. Similarly, for the second partition, if you assign ground truth T2 to C2, what you can see is you only get a 20 over 40, so your recall is 20 over 40. Similarly, for the third one, when you assign the ground truth of T1 to C3, you get 25 over 25. That means the fraction of the point in this partition shared in common with the cluster C sub I, then you get this recall. Then what about F-measure? F-measure actually is a harmonic means of precision and recall. So F-measure for cluster C sub I is the harmonic means of precision sub I and recall sub I. If you transform, the formula will become like this one. Then for F-measure for the whole clustering, what you need is you just need to average all the clusters, the F-measure. That means suppose you get R clusters, then you get F-measure from 1 to R. You add them together, divide by R. Okay. So for this green table, what you can see is what you get F1 is because you got 2 times 30 divided by total is these two add together, you get 85. Then for F2, you get 2 times 20 divided by these two adding together. Okay. The F3, of course, is 1, no matter what you calculate it. Then you average of these three, you get F-measure is this number.